We are doing Unit 4, Investigation 1, Lesson 1. We're going to do the entry ticket together to start off with because we have some terms we need to go over. A lot of this is going to be very familiar because we've worked with these whenever we do some sort of graph. So here we got to define some vocabulary words. So the first one is increasing and decreasing. So we're kind of representing what a function would look like if it was increasing versus it was decreasing. So I'm going to start with increasing. I'm going to use an exponential example. It could be this, just to kind of let you know an example where it's not a polynomial to know exactly what I'm talking about. So here, this is going upwards. As your x values increase, your y values will increase. So this is what we're talking about when it's increasing. It has to be going up. If I were to do decreasing, I'm going to change color here. I'm going to do something very similar, except it's going to go the other direction. This is also an exponential. So it would look something like that. Now that we're working with polynomials have multiple twists, I guess. And if you kind of took a peek down here to this function down here, as you can see, it has kind of multiple bumps and ups and downs, and you don't know which direction it's going to go. So I'm going to give you an example of that because it can not only can it increase and decrease in just one function, you can also kind of show it right here. So let's do this just to give you a different type of example. And here it would be increasing here, increasing here, and then if I were to do orange here, decreasing at this interval, and that's, I think, about it. So, as you can see, you can increase or decrease in multiple intervals in a function. Now we're going to be talking about relative minimum and relative maximum. Just bring your attention to what we did in quadratics. So in quadratics, we had parabolas. Let me just make these more pretty. We had parabolas, so they're either concave up or concave down. Remember smiling or frowny face, right? And they had either a maximum or a minimum. So this is a concave up. And when that's the case, this is an absolute minimum. And this is concave down. So this, at the top, is going to be the absolute maximum. But in this situation, when we're dealing with polynomials, I am dealing with a relative maximum or a relative minimum. And that's telling me that there can be multiple minimums and multiple maximums, so they're relative, not absolute maximums and minimums. So I'm going to do an example here. Let me do a different type of graph. So as you can see here, we have a couple options for both a relative minimum and for both relative maximum. So that's just an example. X and Y intercepts, we're used to dealing with these. This is when Y is equal to 0. They're also called zeros or roots. And this is where the line crosses the x-axis. So if I were to do an example line, I could do this. And the possible zeros are right here. Every time it crosses the x-axis. And I'm going to put a little star here. And I'm just going to give you a little reminder. It's common to have more than one. It's actually common that there's more than two, even. Same thing for the y-axis. So I'll say, let's use purple. And let's do an example. Let's do this. And right here where it crosses the y-axis this is when x is equal to 0, and it is where line. And typically there is one, but you could get something crazy. Like, let's do an example. No, like a graph like that, but that's not very likely. But y-intercept is when x is equal to 0 and where the line crosses the the y-axis, sorry. So there's usually only one. So we're going to bring our attention to this polynomial function, and after kind of defining some of these words, they're asking us to find as many of these possible key terms as possible. So let's start with the easy part. Let's start with the roots and the intersects. So let's color code. So my increasing examples in red. So let's put that in red. So let's say, okay, well, it's increasing from here to here, and it's also increasing from here to here. And I'm going to put in red increasing. And then we're going to now do the decreasing, and we did decreasing in orange. So decreasing in these two areas, these two intervals. Now we're going to figure out our relative minimum and maximum. So let's do green. This might be a relative minimum, and this might be a relative minimum. And there's only two relative minimums. There's no maximum, so relative minimums. So we can't account for any relative maximums. Then we want an x-intercept and a y-intercept. So x-intercept would be right here. X-intercept, and now I want the y-intercept, which is right here. And that's all. All right? So now we're going to kind of move on to another type of graph, and we're going to answer a bunch of questions that relate to it. And some pretty cold temperatures, that is true. The graph below shows a 24-hour period during which the temperature measured in Celsius, that's important, dropped well below freezing. Study the graph and answer the questions, and it says time is t is equal to 0 is equivalent of 12 midnight. So they're telling you right here, this is midnight. So, let's say 12 a.m. We just have to be very careful because this is written in hours at like what time it is. All right, so it says, what was the temperature at 12 o'clock midnight? Well, I'm going to go to my y-intercept, which is right here, and say, okay, well, this is 6 degrees Celsius. And this is from my y-intercept. How much did the overall temperature drop in the 24-hour period? Well, it's asking me overall temperature. So I'm going to write in black here. Overall temperature. My start point was 6 Celsius. End point was -8. And I got that point from right here because this is 12 p.m. and it was -8 degrees out, Celsius. So you want the difference between the start and the end. So if you want the difference, that's subtraction. So I'm going to say 6 minus the -8, which is going to give me 6 plus 8, which is going to give me 14 degrees Celsius total change. And this makes sense because if this is the highest that it was and this is the lowest that it was, it just happens to be that way. Let's actually mark those points. We might need them for later. So this is the lowest temp, and this is the highest temp. So again, if you want to measure the distance, the difference, right? It would be this. So if you actually counted 2, 4, 6, 8, 10, 12, 14, you actually get 14 units of change anyway. Either way you wanted to do it. So, number 3, how many times during the day did the temperature read exactly 0? And at what times did that occur? So let's choose green, and we're doing our exactly 0 degrees Celsius. So I'm going to figure out where my roots are, my x-intercepts, right? These are my x-intercepts, our roots. So we have at 4 hours, and so if this is midnight at 0 hours, then 4 hours would be 4 a.m. So at 4 a.m., then we have 10 a.m., because 10 hours after midnight is 10 a.m., and then we also have one at 20 hours. So this one's going to be a little more difficult because it's going to be 12 o'clock is right here. That's the afternoon. And then we're going to go into the evening. So 2, it's going to go up every 2. So 2, 4, 6, 8. This would be 8 o'clock p.m. So that's exactly where my zeros are, and those are the times that it occurred. And it asks you what times in particular, so you want to give them this answer. You're not going to say the values in hours. Like, for example, you're not going to say 4, 10, and 20. There's no 20th hour. That's not a time, so you can't put that. That's exactly why I wrote it this way. Now it asks, okay, well, what times during the day was the temperature below 0? And explain how you kind of determined those items. Well, let's change color here to light blue. And we're going to say, okay, well, if the temperature is here, and this x-axis, anything below this x-axis would be 0, because then you're going into negative degrees. So the only times that this graph is under 0 degrees is this area, bold it, and this area. Okay. So now it asks, okay, well, explain what times during the day. So, well, what times, I'm going to give an interval. So from 4 a.m. to 10 a.m. And then another interval is from 20 hours. We already established that'd be 8 p.m. So from 8 p.m. to 12 p.m. So it's 4 a.m. to 10 a.m. union 8 p.m. to 12 p.m. That's because it's both intervals, so we're going to combine them. Union is another way of saying and. The reason I put a bracket here is because it's inclusive, whereas 10 a.m. and 4 a.m. are not inclusive. And if you look on the graph here, you're looking at 24 hours of the day. So at this point, the graph is going downward. It's decreasing. So you know that it's below 0 at 12 p.m. And that includes that time period. But if you look at 8 p.m., 10 a.m., and 4 a.m., we've already established from our x-intercepts that those are where it's 0. But it's asking for below 0. So those do not count, and they're not inclusive. You're just going to say that that's the interval, and you're going to have parentheses instead of inclusive brackets. Now it says, okay, well, what time is the temperature at a relative maximum? And the next question is a relative minimum. So we're looking for relative maximum and relative minimum. So I'm going to change colors again. Let's use purple because we haven't used that yet. So relative minimum or maximum, there's one right here. And there's one right here. And that is it. So this one is a relative min, and this one is a relative max. And since this is between 6 and 8, it's going to be probably 7. So 7 a.m. And this one looks like it's at 16. So we're going to say 4 o'clock. So what time is the relative max and then min? So relative minimum is at 7 a.m. 7 a.m. And then relative maximum 4 p.m. Now it says, in question 7, it says the answers for questions 5 and 6 at the highest and lowest temperatures for the 24-hour period. If not, what are the highest and lowest temperatures? So this is what I'm talking about when you're dealing with a relative maximum or a relative minimum. That might not always be. These may not always be the absolute min or max. They say relative for a reason, not absolute. So if I'm looking for the highest and lowest temperatures in this 24-hour period, well, we actually already marked those. So my highest is 6 Celsius and my lowest is -8 Celsius. So 6 Celsius and -8 Celsius. Number 8, what times during the day was the temperature decreasing? And then can you provide an explanation as to why that's happening? Well, temperature is decreasing, it's getting colder, and maybe it's the evening, right? We all know that it gets colder as we kind of go later into the day. So you guys can make up your own explanation for that in your own words, but right now I'm going to show where it's decreasing. So I'm going to show it with red. So it's decreasing. I'm going to actually show it with arrows. So it's decreasing in this interval. It goes back to up to increasing, and then it goes back down to decreasing. So from this point on. So these are the two areas where it's decreasing. At what times during the day was it decreasing? Well, we're going to write an interval, right? So we're going to say, okay, well, from 0 to 7. So 12 a.m. to 7 a.m. goes union 4 p.m. to 12 p.m. And during what times during the day was the temperature increasing? Okay, well, let's do increasing in green arrows. Well, it was decreasing from there with the red, where the red arrow is, and then it was increasing back this way, and that's the only part it really increases. So it's from 7 a.m. to 4 p.m. 7 a.m. to 4 p.m. And then it says, what is happening at the beginning and end of this graph? Should the arrows be placed on those ends? Well, why or why not? I'm going to let you figure the answer to this out yourself.